Do you know this guy? This is Michael Bloomberg, and he can tell you a thing or two about how important it is to evaluate the effectiveness of your marketing campaigns. He recently spent $500 million on his presidential campaign just to drop out shortly after. So in order to avoid wasting such an amount of resources and also the ridicule that comes with it, we can do something called uplift modeling in order to customize the selection of customers we actually include in our marketing campaigns and also customize at the individual customer level. My name is Marius Leckelt, and for the past 6 weeks, I've worked with faculties, research and development, and marketing teams on exactly this problem, how to do uplift modeling using deep learning. So again, what is uplift modeling? It is a way to evaluate the effectiveness of marketing interventions, such as sending someone a catalog or showing them an advertisement, and then answering the question whether or not this intervention actually translates into increased revenue or sales. We do that by comparing two alternate realities, one where people have seen and have gotten an intervention, and another one where they didn't. Then we can take the difference between these two realities, so to speak, and get our uplift that is due to the intervention. Faculty are currently doing this for a large US retailer using a two-model approach based on gradient-boosted decision trees. In a first model, you model the buying behavior of customers who didn't get an intervention, and then in a second model, you use that information combined with the data on the people who've gotten an intervention. Then, by taking the difference between these two models, we can get our uplift scores. However, there are two drawbacks with this approach. First of all, tree-based methods have to be retrained quite frequently, and also uplift modeling has a very low signal-to-noise ratio, which calls for maybe more subtle techniques to actually detect this weak signal. So what could be this ultimate algorithm that helps us in solving these problems? Well, currently there might be deep learning, a state-of-the-art technique in many different fields, very versatile, however computationally expensive, data-hungry, and notoriously difficult to understand. So now we want to know, does it also work for marketing interventions and human behavior? To answer that question, I've used data to improve catalog mailings for 1.2 million customers of a large US retailer, implementing non-standard neural networks with Keras on a TensorFlow backend. So how exactly do we do this? Again, we use two different models. In one, we model the buying behavior of people who've gotten no intervention, and the second one, where we use neural networks to model the behavior of people who've gotten an intervention. Now, the tricky part is that these two streams of information have to be combined in an additional hidden layer, and we have to ensure that that the information of both models is actually used to get our uplift scores. This always involves a lot of experimentation, and I've tried different numbers of layers, nodes, optimizations, activation functions, and so on. And after many setbacks, I was finally able to build a model that increased 13% on the customer's current model. So this means that by using my model, you improve sales or revenue by 13% for each catalog you send a person. However, faculty's tree-based method actually improves 28% on the retailer's current model. So where does this leave us? Well, we can conclude that deep learning may be used for uplift modeling. However, it is no panacea and solve all our problems. On the contrary, I could show that tree-based methods actually work better for this kind of behavioral data. Now, how does it help us finding out what happened with Michael Bloomberg's campaign? Well, some of you might say he obviously used the wrong modeling approach, while others might say, as is often the case in political campaigns, the product was just bad. Thank you.